Hello everyone, I am Xiaogang. Now let's look at removal. Let's look at removal. This removal is remove, meaning we provide a key for an element. Then it will remove the key value pair corresponding to the key. And it returns the number of removed elements. If there are no elements matching the key, it returns 0. Okay, we might need to test them one by one. Okay, let me explain this part in more detail. Because for a container like n app, actually, the one we use most often is this. Removed. This kind of data structure. Actually, we designed it in order for us to remove. Alright, even with something as simple as this. If we write upwards, it won't work. This way is convenient for us to find it. Here, it removes element 8. We attach one like this. Just replace it. Then, if we remove this place, we select item 5. Then we select item 8. Then we need to connect this place. Because when we click the circle, you can see that it removes all the O values corresponding to this K, right? O value, and then is this area using a mute map? Maybe ours is a TMap. Or could it be a mute map? Just talking about a TMap for our area should be enough. Because fundamentally, the ideas are quite similar. This is a stem 312. So let's pay attention and take note of it. Key wool. Q remove. Be careful, this place returns the number of items removed, not the index that was removed. That is, we don't have the concept of order. Don't ever follow that. Put it in this order. Then let's run it here. Okay, after we get in, we'll put this part here. Just saying xt here will be fine. Okay, let's set the breakpoint. Then we execute. Okay, after coming in, there is a map here. There are 3 elements, and then 1 was removed from this spot. Then there are only 2 elements. It is like this. And then here, we can see that an element was removed. No element was removed from the side. So what is repeatedly happening is we can see that if we write one here, if ki greater than, then we prove that an element has been removed. Then we might have to perform some operations. For example, when we stack buffs, the time for a certain buff runs out, or a matching buff was successfully removed. We can perform operations here. If we can also write one like this, etc. and u. The problem brought by doing this, that is, you have to write another condition check. So, are there any other better ways? Let's take a look here. Can we find his vocal timbre? Is vocal timbre. Maybe it means this, it's what you see. If we remove, actually, we took a wrong turn here. It should be here. Wait a moment. We can take a look at this visualization projection. Let's set a breakpoint. After entering here, we haven't removed it yet. Actually, you can see that there are 3 elements here, 0, 1, 2, and after we execute it, you will notice that this element is removed. And actually, this place was set up as. After that element is removed, it was restored to our slack element. So this is the visual projection. It should be this thing. What we need to look at now is this. If you don't want to do the closing check, there will be a check here. Meaning it will definitely check if this thing moves out successfully. If it fails, there will be an assertion like this. Then we can try this. So the same thing, let's just put it here. Or we write a new one. Actually, in many situations, many times when we are developing, it's just many. Although you want a function, you think this feature, if you expand it a bit more, it would be particularly useful. Then your first reaction should be to check the engine. whether it has implemented for you this related functionality and related classes. Most of the time, the engine has already implemented it for you. Then you can just take it and reuse it. There's no need to start reinventing the wheel, because building the wheel, it actually takes up a lot of time sometimes, and after you build the wheel, it might not actually be written very well, nor is it necessarily aesthetically pleasing. I mean, that situation can exist. Then we also pass it to this K character. Pay close attention. Let's read this circular code. We just need to find this. Find its corresponding pair using the given K character, then remove it from this map and simultaneously return this fidelis to you. If it is not found, here we'll throw an exception. Then it will check inside here whether this pyro's ID exists, right? Then we can call an endpoint to check. Okay, so this part, the 5 must be successful. Then regarding the remote 5, so it should return something like this mango. Let's just close it. If you find this too complicated, you can also write the code in VS and then compile it in the editor. Yes, actually, I'm used to launching it from VS. Okay, we're all set. We are going to call it now, because we need to set a breakpoint. Because you want to set a break. So in this part, we must use this VS. Like this debug, you need to attach this process. So we still have to start from VS in this place. We can also see the breakpoint here. But sometimes when you write code, maybe we don't need to go through all this trouble. You can just edit it where you write it. Once you're done writing, you can edit it in VS. You can see that there aren't any issues here. It should be successful here. Then we will move out of failure here. Look at this check. This check is false. You'll see this check condition. So there will be a breakpoint here. Let's continue going further down. Another check is performed here, meaning this is invalid. Okay, so we will download it after setting the bubble. Basically, your program won't be able to run further. This means that this is the reason why we don't allow you to use this check. Because when some people or certain people use this feature, it can lead to significant deviations and mistakes in everyone's work. This results in development being blocked. Therefore, please try not to use this check, only for extremely severe errors. Should you use this check? Okay, let's go look down here. As for this place, we might have a way to salvage it, but it's not very appropriate. So you can drag this breakpoint outside. It's roughly a situation like this. We might be able to temporarily salvage it. Then this remote copy values. It is similar to this remote. The difference is that it will copy the value of the element to be removed to the reference parameter. If this value does not exist in the mapping, the output parameter remains unchanged. It will return false. So this part is a little complicated. In fact, it just passes this string in. If this value is found, we will copy this value into the variable that was passed in. If it wasn't found, what was its original value? It just remains as it was. We won't modify it. So that's the general idea. Okay, let's briefly use this RemoveAndCopyValue method. Actually, the idea behind this thing is somewhat similar to, sometimes we have something similar called tgraph. Maybe, I don't remember the name of this. Regarding this thing is actually very useful. But maybe most people won't be able to use it. It is also a template. Let's see if we can click into it. You can see, it's actually a temporary storage for setting this value. Just save the old one first. And then, after you're done modifying it, you can revert it to the previous state. It's actually pretty useful. Most people might not need this value. If you write the code yourself, it might be a little difficult to write. If you write it more systematically, you might notice that when you construct it, save the old data, and then when loading, you go back and set this old data. The basic idea is like this. I want a value that changes within this range. But after this range ends, I make it revert to its original state. This thing is pretty interesting. Let me share a kind of method with everyone. As long as there is an engine with such a fun implementation, that's fine. If you have time, feel free to check out more. When you look at a function, when you call it, you should take a look at how it was implemented or how it thinks. After looking at it more, you'll probably understand how the engine works. Then, regarding this part, let's give it a... Actually, it's just my personal habit. I prefer to put an initialization step here. Of course, if you don't want to, that's fine. Because F is military though. It has already helped you. You go collect the lethal one. It has already turned it into a public thread. But personally, I prefer giving this word. And then the spot is, we change the calculation to 5. After calculating it to 5, you can see that he will only move out of this formation and put this value to move it into this, inside this. That is, copy this value to the reference that you passed in. So we move this value out and assign it to him. If we don't move it out, its original value won't be modified. Let's set a breakpoint here to demonstrate for everyone. Hello. Okay, same old routine. I will later in this place. For my later chapters, we might just cut out this section if it's the same. We can just cut it out to prevent everyone from constantly looking at this and setting breakpoints. This might look better because we've already performed this operation many times. As you can see, the value here has changed to mango, and we didn't find it here. Actually, it will also return a false. This value actually hasn't changed. This place is because it was absorbed, but it clearly hasn't changed. This is because of the absorption. It means that if it finds it, it will rewrite this word. If it doesn't find the word, nothing happens. This place returns a force. It's that simple. Okay, then we continue to look below. Finally, we can use NPD and reset. We can also remove all elements. So let's just take a quick look. But NPD and reset are different. PT actually passes parameters to tasky, which means you can clear this array, then initially send it to a specified slack amount, and set as much of the amount flowing out of slack as possible. Let's implement it. Okay. Let's write 2 here. We'll write 2. Actually, we have a catagraph here. We'll just write an empty one. An empty map will be fine. This spot. Set map. Okay, and similarly, here we do something. We give it this one. And then here, dots. Just drop an empty. If you pass this NFD, it might be initially converted to, let's pass a 0 actually, completely empty. You can see, remove all the elements. Yes, you can set the default here to 0. We could actually set this to 10 here. We can take a look at it. To avoid other problems, we need to give you instance 2. This is to avoid it ending. We need to do this. We can do a reset here. We can take a look. This reset means efficiently clearing the velocity. But try to keep as much of the already allocated memory capacity and space as possible. We can take a look. Okay, here we declare 2 things. Then we'll add another one here. This value can be the same, but the key might not be. The keys cannot be the same. Okay, let's add one here. There's a small trick here. You can press and hold Alt like this. Press and hold Alt to do this. Deep carry theta 的字. Let's start it up. Then we'll proceed with debugging. We skip the blueprint stage in between. You can see, notice that now number 23, max 14. Proving there's a slack element. After we clear it, you will find that it's gone. Both number and max are gone, but if we set it back to 10, you can see that number is still 0 point, but max does. Max proves there are 10 slack elements. Next, let's take a look here. Let's take a look at this. this should, it keeps going. It might get stuck. Let me fix it. Let's keep looking below. You can see this area, empty. And then this should be 3 and 4. If we reset it, its capacity hasn't been released. It only emptied the elements. And then here, we also can see this second one here has already expanded its capacity, 5 and 22. Let's reset it, because we found that it only clears this. That is, it only empties the contents of this object, but the maximums that were allocated inside it, none of these have changed. So this is the difference between reset and empty. Okay, let's continue watching. Actually, concerning this area, removing this should be sufficient. Also, it has another function here called reverse. We've already written it. Let me show you all. We'll gradually increase the speed. This reverse actually pre-allocates enough memory to include a corresponding number of elements, and then you can look at the specific implementations within it. So we won't worry about this implementation. We will directly see what its resulting state is. We spawned a map here, and we pre-create 3 elements, and then we conceive, and then we add these 3 elements. So if our capacity is 3, we can guarantee that adding these 3 won't require gressing. Then we pre-allocate 10 and then change the spot to 2. Let's see what changes they each have. Okay, we'll just execute it here. Okay, you can see that it's 0 now, and then you assume it needs to store 3 elements. It's actually maxed out, so that's not a problem, okay? So in this case, it won't scale up. If we scale up to 10 now, you'll see that it becomes 29, right? It becomes 29, then we set the capacity to 2. In fact, it hasn't changed. So it's basically trying its best to, what this function means is that it tries to see if this element's number container can hold this many elements. If it can, then I do nothing. If it cannot, then I expand its capacity. So this reverse should mean this. Okay, so we'll stop here.